All right, this is the second part of the 9.3 lesson dealing with geometric sequences and series. So quite honestly, this is the series part of it. If you'll remember the difference in those words, sequence is the actual pattern that extends forever. Excuse me. Series is the sum of that sequence. So we're going to deal with two different scenarios. We're going to talk about the sum of a finite sequence, and then we're going to actually roll into the sum of an infinite sequence. So these formulas are on your little yellow formula sheet, so make sure you have that handy. I wouldn't want to memorize these things either. So when you look at this formula here, make sure that you're understanding in your problem. This does work for finite. Remember that you have a stopping place. It ends. It's going to stop, and it's a geometric sequence. So you're multiplying or dividing to get to the next term. So whenever you have that, see, this part looks like the geometric sequence that we were talking about earlier. You have your first term right here, then you have your common ratio, and this is, we normally had n minus 1. They swapped it out to I minus 1. Don't let that throw you. It's all good. Same stuff. A sub 1 is still the same thing. A sub 1 has always been. A sub 1 is first term. Okay. And then R, same thing he's always been. Both of these places is common ratio. Now N, that might be a little bit different. N, that is the number of terms you have. The good thing is, if you have this nice little sigma notation or summation notation, whichever way you want to call it, if they give you this notation, it is always the number at the top. So if they don't give you that, then n is the number of terms. So if I ask you to sum up the first 50 integers, like I did on that last quiz, there are 50 integers, so you would put 50. But if I say, what is the sum of the even integers up to 20? Well, only half of them are even, so there'd be 10 of them, so you'd put a 10 there. So it's a definitive number. It's how many terms you are adding together. So here's our first problem. It says find this sum. Now if you just look at this, and let's list out what we have. A sub 1, remember he lives right here, that's 4. R, same place he's always been, 0.3. And then N, there he is, up top, 12. So as long as you have it written in this notation, N's not a problem. Now we just need to use our lovely little formula. S is equal to A sub 1 minus R to the N, over 1 minus R. Then you can come in and put in your information. I've got 1 minus, and it's going to look a little weird, but you should be just fine. I highly advise you to grab one of your calculators. The TI-84s are terrific here. This is where you want to use that huge fraction. You press your green button, your y equals, and enter, and it gives you that nice fraction, and you can do this big fraction notation without any trouble. Otherwise, you're going to have to do it little piece by little piece by little piece, but I highly advise you to use your super fraction in your calculator. Once you type all this in, you can just round it, and you get something close to 5.7. So just find you a convenient place to round. Those aren't a big deal once you know what your formula is. Now, then you're going to swap gears, and this is the formula that you're going to use. I'm going to bump it up for just a second. This is for an infinite geometric series. Well, infinite means it never ends. Now, if you get to thinking about that, it kind of make your head hurt, because you're trying to find the sum of a series or sum of a sequence that never ends. Well, if you've got a sequence that's like 2, 4, 8, 16, 32, 64, and it's just getting bigger and bigger and bigger, and it never stops getting larger and larger and larger and larger and larger, then there's really no way for this thing to have a sum. It's not going to, because this thing is called divergent. It has no sum. Okay? What you're looking for and what you can take the sum of is series that they converge. So they're zoning in on one particular value. So basically, if we took this entire thought process from this nice little sequence that I gave you, but instead of it being integers, what if this was, oops, got a little happy there. What if we did this in terms of fractional values? So what if it was 1/2, and then 1/4, 1/8, 1/16, 1/32? This is zoning in on something. If you keep going, this is getting closer and closer and closer and closer to 0. Those things, those sequences, you can take the sum of. These converge. Convergent, or they converge, and they do have a sum. So make sure you know which one has a sum and which one doesn't. The ones that you can take a sum of, you're going to use this formula down here. And notice, it's the same basic setup. It's got to be geometric. There's your first term. There's your ratio. Notice up here for n, remember it was number of terms. We're talking infinite, so it shouldn't be a surprise that there's infinity up there. The formula is rather simplistic. A1 over 1 minus r. So it's not going to be hard to use. So let's look. It says find each sum. Well, let's see. We have S equals a sub 1 over 1 minus r. Well, that means a sub 1 is 4, and r is 0.6. All you have to do is, you could use your nice fraction in your calculator, type that in, and it'll come right out. Or you could work that out. 4 divided by -4 is just 10. This is converging. And the way you know it's converging, just a little hint here, you see your ratio is a value in between 0 and 1. That lets you know that this thing is converging. Okay. Like earlier when I was showing you that converging series, and every time it was this fractional value. See, your ratio here, we were multiplying by 1/2 each time. When your ratio is in between 0 and 1, you get a convergence. When that happens, you can actually get the sum. It's kind of neat. So, on the second example, you actually have to look at it and determine a sub 1, but that shouldn't be a problem. Now, finding r, just remember how to do it. Take any term. I'm kind of lazy. I take the second term and put it over the 1 in front of it. Reduce your fraction. So when you reduce that fraction, it is 0.1. Now, it's formula time. 3 over 1 minus 0.1. When you work this out, you get 3.3 forever. That's pretty much it. Practice on those. Make sure you've tried enough homework problems. Y'all still have homeworks that are due for 4th 9 weeks. We are at the progress report time, so don't quit. There are 7 sections in Chapter 9. This is the 3rd section. So stay on top of things. Finish strong.